Good day, everyone. Today we will discuss the DES or the Data Encryption Standard. And these are the content. First, what is DES or the definition of the Data Encryption Standard? Next, what is DES algorithm in cybersecurity? Next, the history of DES algorithm. Next, the Data Encryption Standard algorithm steps. Then, another one is the algorithm process breaks down into the following steps. And next is the encryption process steps. And then the advantages and disadvantages of DES algorithm. And lastly, the steps for encryption, an example of DES. What is DES or Data Encryption Standard? DES stands for Data Encryption Standard. There are certain machines that can be used to crack the DES algorithm. The DES algorithm uses a key of 56-bit size. Using this key, the DES takes a block of 64-bit plain text as input and generates a block of 64-bit ciphertext. The DES process has several steps involved in it, where each step is called a round. Depending upon the size of the key being used, the number of rounds varies. For example, a 128-bit key requires 10 rounds, a 192-bit key requires 12 rounds, and so on.
What is the DES algorithm in cybersecurity? The DES Data Encryption Standard algorithm is a symmetric key block cipher created in the early 1970s by an IBM team and adopted by the National Institute of Standard and Technology. The algorithm takes the plain text in 64-bit blocks and converts them into ciphertext using 48-bit keys. Since it's symmetric key algorithm, it employs the same key in both encrypting and decrypting the data. If it were an asymmetrical algorithm, it would use different keys for encryption and decryption. So, what is this algorithm? Paano ba ito gumagana? Ang algorithm na ito ay nagbabago ng 64-bit na plain text block papunta sa ciphertext gamit ang 48-bit na mga key. At dahil ito ay isang asymmetric key algorithm, ginagamit nito ang parehong key sa pag-encrypt at pag-decrypt ng data. Kung saan ito ay isang asymmetrical algorithm, magkakaiba ang mga key na ginagamit para sa pag-encrypt at pag-decrypt. So, bakit ito mahalaga sa cybersecurity? Ang DES algorithm ay isang magandang paraan upang masecure ang data laban sa mga hackers at cyber attackers. Kung ang isang attacker ay makakakuha ng access sa encrypted data, hindi niya ito magagamit dahil kailangan niya ng tamang key para ma-decrypt ito. Kaya naman ang DES algorithm ay isa sa mga pinaka-importante at matagal nang ginagamit sa algorithm sa larangan ng cybersecurity.
History of DES algorithm. DES is based on the Feistel block cipher called LUCIFER, developed in 1971 by IBM cryptography researcher Horst Feistel. DES uses 16 rounds of the Feistel structure using different key for each round. DES became the approved federal encryption standard in November 1976 and was subsequently reaffirmed as the standard in 1983, 1988, and 1999. DES dominance came to an end in 2002 when the Advanced Encryption Standard replaced the DES encryption algorithm as the accepted standard following a public competition to find a replacement. The NIST officially withdrew FIPS 463, the 1999 reformation in May 2005, although the triple DES remains approved for sensitive government information through 2030. So, the data encryption standard is a symmetric key algorithm for encryption that was developed by IBM in the early 1970s. It was adopted as a federal standard by the United States government in 1977. Ang DES algorithm ay batay sa isang Feistel network at gumagamit ng block cipher upang i-encrypt ang data. Ito ay malawakang ginagamit noong 1980s at 1990s para sa pag-secure ng data sa mga computer system. But concern about its security emerged in 1990s as advances in technology made brute force attacks against the 56-bit key length possible. So the DES algorithm was eventually replaced by the Advanced Encryption Standard algorithm in 2001. Although it remains an important part of the history of cryptography and has influenced the development of subsequent encryption algorithms.
DES algorithm steps. To put in a simple terms, DES takes 64-bit plain text and turns into a 64-bit ciphertext. And since we're talking about asymmetric algorithms, the same key is used when it's time to decrypt the text. So, this is the process or steps of DES algorithm. Number 1. The process begins with the 64-bit plaintext block getting handed over to an initial permutation or IP function. Number 2. The initial permutation or IP is then performed on the plaintext. Number 3. Next, the initial permutation or IP create two halves of the permuted block referred to as left plaintext or LPT and right plaintext or RPT. Number 4. Each LPT and RPT goes through 16 rounds of the encryption process. And number 5. Finally, the LPT and RPT are rejoined and a final reputation or FP is performed on the newly combined block. And lastly, number 6. The result of this process produces the desired 64-bit ciphertext. The purpose and importance of DES algorithm is to ensure the efficiency and standardization in data encryption, confidentiality, and integrity of data being encrypted, and also to ensure that the encryption process is secured.
The advantage and disadvantage of DES algorithm. The advantage of DES algorithm, it is a set of a standard by the US government. When compared to the software, it works faster on hardware. Triple DES use a 168-bit key, which is very hard to crack. The disadvantage of DES algorithm, weakly secured algorithm. There is a threat from brute force attack. A DES cracker machine, known as crack, is available in the market.
Steps for encryption. There are multiple steps involved in the step of data encryption. Number 1. Permutate the 64 bits in the plaintext and divided them into two equal halves. Number 2. 32-bit chunks of data will undergo multiple rounds of operation. Number 3. Apply XOR operation in between expanded right plaintext and the compressed key of 48-bit size. Number 4. The resultant output is sent to further step known as the S-box substitution. Number 5. Now apply the XOR function to the output in the left plaintext and store it into the right plaintext. Number 6. Store the initial right plaintext in the left plaintext. Number 7. Both the LPT and RPT calves are forwarded to the next rounds for further operation. Number 8. At the end of the last round, swap the data to LPT and RPT. 9. The last step, apply the reverse permutate step for the get of ciphertext.
Step for decryption. The steps involved in the steps for data decryption are: number 1. The order of 16 48-bit keys is a reverse such that key 16 becomes 1 and so on. Step 2. The step for encryption are applied to the ciphertext. For example, take the message: your lips are smoother than Vaseline. This plain text message is 38 bytes. 76 hexadecimal digits long. So this message must be padded with some extra byte at the tail end for the encryption. Once the encrypted message has been decrypted, these extra bytes are thrown away. There are, of course, different padding schemes, different ways to add extra byte. Here, we will just add zeros at the end so that the total message is a multiple of 8 bytes or 16 hexadecimal digits or 64 bits. Here are some of the example.